Hello everyone, this is Reza. Welcome to another video of FX series in Maya. In this video, we are going to create a realistic fire effect using Bifrost extension. Now in previous lessons, we already covered how to achieve the same look using fluid simulations. But Bifrost extension is what I think would be the future of FX inside the application. So let's have a look at how to create or how to achieve a pyro-dynamic effect using Bifrost visual programming tools. Let's get started. Now, just to give you a bit of a hint on what these guys are doing here, you don't need all of them enabled for pyro-dynamics because Bifmesh.io and then Shell and Bifviz plugin are for Bifrost liquid. So we're not going to use them today. Boss is Bifrost ocean simulation system, and we're not going to use this one either. So basically, the only one that we're using is Bifrost Graph, and there's another one called VNN. If I type it in, Maya VNN plugin, that is linked to the Bifrost Aero. But having said that, as soon as you enable Bifrost Graph, the other one should get enabled automatically. So you don't need to manually enable that every single time. All right, I'm going to close and go straight into, you can either click on this icon here on your shelf, Bifrost shelf, or you go to Windows and then you go to Bifrost Graph Editor. So that's where you create all of your nodes inside Bifrost. I'm just going to go create new graph. And we don't have anything just yet. We have the output, which creates our BIF file. We don't have any. And we have our input, which is currently empty. I'm going to get rid of that input and use an internal node inside Bifrost to create my emitter. You can always drag and drop your emitter in here and create it. But for the sake of simplicity, I'm just going to go to modeling, primitive, and create a simple sphere. And every time you see that diamond icon in here, that shows that it's an internal node, and we're good to go. Now, the simplest form of creating a Bifrost graph node is just to simply select the in, select the out, to in output, and then we have something. Now, that something is not going to do anything because we don't have any simulation. If I play, I just get a flickering image. There is no gas, there is no simulation. But what I made is this BIF file, BIF01. And every time you want to load this scene, you can actually click on this plus button and load that graph into a new pane if you want. Now, obviously, this is not going to work because we don't have any simulation. So I'm going to unplug it. Just simply left mouse, drag to unplug. Now let's think about the main components we need for every simulation. Obviously, we need to turn this geometry into volume. So we need to turn it into a gas. In a simpler term, to do that, we need source air. So that's one of the nodes that you always use to turn your emitter into a gas, and from there you can just do your simulation. Now this source air defines the properties of your emitted gas. So basically you've got a lot of attributes to deal with, but we're going to look at them later. For now, we just want to construct a node and get the ball rolling. Now I can easily go from sphere mesh into geometry because there's an input for a geometry. It says, well, where's your geometry? I want to turn it to gas. Remember, we're still not going to see anything because nothing is connected to the output, but we don't have any simulation either. So let's create our simulation. You just type in simulation, it's Aero. Now it says, well, where's your source? If I zoom in and actually go full screen like so, it says, well, I need source. We have source air, goes into source, and aero volume goes into your output node. Now we should get something if I play. You can see a puff of air has been created and it rises up because of the buoyancy attribute that we have. Nothing too complex, very, very simple. That's the simplest form of getting some sort of a aero effect inside Bifrost graph. So these two components you definitely need to have in order to get started, but we know we're close to finish. So let's see what else we need in order to move forward. Now, every time you simulate something, you can see the simulate tab is completely empty. And this simulate aero computes the simulation. You cannot change any attributes on it. It's like an engine of a vehicle. It just turns things into physics. So we need to tweak its settings. Every time you want to tweak settings for simulation, you can see we have settings here. So I'm just going to go and type in settings, and we have Aero Solver settings. Now we have different types of settings: combustion settings, sharpening settings, and adaptivity settings, but we are doing aero simulation, so Aero Solver is a no-brainer. We are going to select that, and you can see Solver settings goes to settings, and now we can have access to the settings for our aero simulation. Very cool. Now keep that in mind. Every time you use source air, you're not only enabling density, but you're also enabling temperature. Now we are not going to see any coloring information because we haven't even started with materials, but what we see is a combination of density and temperature. So let's go in there into source air and tweak a few things. Obviously, to shut down the entire simulation, you need to disable your source air. That's why we've got this tick box. Start frame is set to 1. If you have pre-frames, you can go negative, and you specify the end frame. My end frame is the time slider end frame, so I'm not going to tick that. Now this resolution rollout is quite important actually. Fluid detail size is the actual resolution of your simulation. So I can actually lower it to something like 0.025 and get a much crisper density and temperature. And this relative mode is also important. When you set this to absolute, the detail size is in worlds unit. If it's meter, meters, cm, cm, and but with the slightest change, you see a huge difference. Whereas if it's set to relative, simulation with large and small emitters have roughly the same number of voxels. So it brings a sense of stability, and you don't need to constantly worry about the size of your emitter. Also, geo detail size plays a huge role in the accuracy of your scene and your simulation. I'm going to lower this down to probably 0.03 as well. Now, the temperature is something that you need to play around with and see what attribute works best for you, but usually with the scene scale that I have, 250 is super high. So something between 20 to 50, I found that it works best for the fire effect that I would like to get. Otherwise, everything is going to be oversaturated white color, just too much temperature. And I set this temperature mode to over, and that basically blends a source into your property channel. And right now my property is temperature. Now the rest is pretty straightforward. I'm not going to touch any of these. We've got inherent velocity, we've got the speed, which we can change at any point of time. I don't have any idea how slow or fast the simulation is going to be, so I'm not going to change any of these attributes ahead of time. Let's move forward and see what we can get. Now I have my resolution set to a good value, and I've got my temperature all set up, let's think about two things. How we can make the flow look more interesting, and how we can make the temperature to react to ignition. So basically we need fuel. Now to randomize your air, you can basically bring in a vary node, which is going to be huge help with randomization. If I just type in vary, you can see we've got vary source property. And usually that's super helpful when you want to just add a little bit of randomization to your either density or fog or temperature. So I'm just going to unplug this temperature, bring it to geometry for our vary source, and then from out geometry into temperature. Now, if I click on this, we need to define what sort of property we need to deal with. Obviously, you can introduce fog, which is our density, you can introduce fuel, or you can introduce temperature. Now, fog we definitely don't need, or because that's density. When we want to create smoke, we need fog, so that's out of the question. We don't need that. Fuel we haven't even started yet, so the obvious choice would be temperature. So make sure there's no typo in here and just drop that in, and as soon as you click that, you create that link and you will add some sort of a randomization to it. But you can see that there is no randomization right now. We've just linked the channel, but we need to punch in some numbers, and this is something that you can trial and error, and that's totally your artistic decision. I'm just going to give it min and max of 20 to 100. I usually don't go over 100, otherwise you will be getting some really weird results. And then we want this to be animated, and seed is the level of randomization. We don't have any color set, so forget about that. Now let's with that, let's do a quick play blast and see what we're getting right off the bat. So we don't have much. Everything is just very basic level of details that we can get with this amount of nodes. But let's just don't get ahead of ourselves. Let's have a look at the results so far and see what we can deal with. Now just keep that in mind that I've got fog set to 0.02, which is super low. I can actually bring it to a very high value just for the sake of demonstration, but eventually we are going to turn this to 0, 1 or 0, because we just want to focus on temperature. But for the sake of demonstration, I'm just going to increase fog density so we see what we're dealing with. So I'm just going to go play blast and do a quick play blast, and we'll be back in a minute. So that's what we are getting. Now the flow is not interesting enough because our emitter is not interesting enough. Always keep that in mind. If you've got a too simple of an emitter, which we have, a simple sphere, the result is not going to be as good. And you may have noticed in my previous tutorials, I tend to add noise to my emitter a lot, either through textures or a deformer, to just make the look of the emitter more interactive and dynamic, and that will have a huge impact on the look. Also, another problem I noticed is the flow is very boring, and on top of that, this flow, it just goes on, arises forever. There is no dissipation, which is not a good idea. So let's address those, and then we can think about coloring and how we can kind of texture that. Back to Maya, and let's address those small things one by one. Now, every time we deal with an internal node, we have a compound, and this is the icon for the compound. So we can double click on the node, and this node has been created by some other nodes, and it's not editable, right? So this is an internal compound that Bifrost made for us. We can have a look, we can take a peek, we cannot change. But sometimes there is a compound that it's custom made. Someone manually made that compound, such as a noise operator that we have right here. So this noise operator is basically a custom compound. If I double click on it, you can see the internal or inside of this compound, if I press L to organize it, you can see that we've got multiply noise operator here just to add randomization to any object that it gets. So if I were to add my sphere to here and view it, you can see we've got a little bit of noise on it. Very similar to mountain sop in Houdini or even texture operator in Maya. The way that you work with it is actually very simple. You go from here into mesh and from out mesh into geometry. Now, if you click on it, you get to have magnitude, how strong the noise is going to be, frequency, how small or large the frequency of the noise is going to be, and how fast it's going to move. So we've got pretty much everything that we need apart from noise type. Everything is in here. Now there is, so if I were to just, with that alone, if I were to play, and I'm just going to play it a little, we can see instantly we are getting some very interesting results. So that pattern is not as soft, which is great, but I still would like to make further changes to randomization of this unit or this graph that we have. For that, I'm going to introduce another custom compound. Again, I will share this script with you, so hopefully you will have access to this. And this is nothing but just a random expression, for lack of a better word, because we cannot add expression in here. We cannot keyframe any attribute. So if I were to keyframe, let's say in random variation or even in general, if I want to keyframe multiplier, there's no way I can do that. So having this little compound is going to be a huge help. Again, shout out to Autodesk community page. So randomize operator, you can just, add a little bit of randomization. So the value I have is min and max set to 0 to 1, and you can plug that in to your multiplier. And that's going to add a little bit of randomization to your multiplier. So if I have a look at here, you can see now multiplier gets a little bit of randomization. Everything looks good in here, but I still don't have any fuel. Now let's see how we can add fuel to our graph and really take things to the next level. So if you press tab and type in fuel, we have source fuel, very similar to source air. If I were to create it, you may think, well, maybe this goes to source. You can actually plug that in, but you're not going to get any result because source fuel always a subcategory of source air. A good lesson, always think about the hierarchy. You need to create gas and only then add fuel to the already created gas. So the fuel node by itself doesn't have enough power to change your simulation. The only way that you can affect it is through your source air. Now let's see what we have in here. Start frame, end frame, and then we have methane fuel, which is we call this fossil gas or sometimes natural gas. That's actually, I found that works the best because it's got nitrogen, it's got carbon dioxide, a little bit of hydrogen sulfide. So it's one of those things that when you think about creating fire, you need to think about what would be the substance, what causes the fire, and based on that you can change the fuel type, and we've got a ton to change. But again, the default is just natural gas, and that's what we're going to use for right now. Now, again, ignition temperature, it's way too high. You need to reach that level so the fire can ignite, which is crazy. We lowered our temperature to 20, so I'm going to set our ignition temperature also to 20. And then oxygen percentage, I usually set that to 1. I really didn't get much luck with other numbers. And the burn rate usually between 0 to 2 would be a good happy medium. If you set it to 0, you turn your fire into smoke, completely smoke. So you may want to lower this value just a tad, something like, I don't know, maybe 0.01 or 0.015, but never set it to 0, otherwise you're not going to get fire really. Now, with that done, before I do a play blast, there's one more problem with the previous play blast that we wanted to address, and that was the dissipation, that endless rising up, which is not the case for fire. Now, if you think about dissipation and where to find it, it's actually an influence. So if I type in dissipation, influence, you can bring it in and it just plugs in straight into your simulation Aero. And then you can just specify the property. And the property we are going to specify is obviously fog density, because that's what we have. And then the rate, the higher rate, the sooner the fire is going to disappear. I'm going to start with 6, which is fairly high, but I may actually lower it if I see that smoke stifles quickly. Now, one last change before we play blast, and that is just on the emitter itself. You may have noticed that mushroom sort of effect that we were getting. Part of it is because of the low resolution on the emitter itself. Obviously, you have higher resolution, you get better noise, and with better noise, you get better temperature flow and much more interesting patterns on your fog density. So I'm just going to kind of crank it up to a super high value. It will slow down the scene and our simulation a little bit, but unfortunately this is something that we have to do just to get a good understanding of the flow that we're having. Radius of 1 is probably a little bit high, so I'm just going to lower the radius, make the sphere just a tad smaller. And transform position is going to be a positive Y, and up axis is Y, and that's it. That's all we need to do. So yep, let's minimize, rewind, and do another play blast, and we'll be back in a second. Now you can see, obviously, as I have predicted, the dissipation is too high, so that's one thing that I'm going to change. I still think I can do better with the resolution. I can lower the resolution just a tad, and maybe I will change the speed. But all in all, I think it's an improvement. We got rid of that kind of mushroom, very flat looking fire. And the reason that we don't see colors and the fiery colors because of the materials that we don't have, and also the combustion node that is missing. So let's close that. Go to our simulation. First things first, I'm just going to lower this to something like 4. Lower the rate for our dissipation. And then I'm going to go to source air and reduce the geo detail size to something like 0.2 and fluid detail size to something like 0.015. Now we need to think about getting rid of this fog density, but for now I'm just going to keep it because I still need to add our aero combustion settings. So we've got fuel ready to go. It's not doing much at the moment because there is no combustion node, and that combustion node controls how the fuel burns. So I'm just going to add aero combustion settings, and that kind of helps this aero simulation to bring combustion into calculation. Aero combustion settings always goes to additional settings in your aero solver. If I click on that, we have few attributes that we need to change. This combustion smoothness smooths all the jagged edges in your fire, so increasing it would soften your fire. Bad idea. So I'm going to actually 0.2 lower it, because we need crispiness. We actually want to have that as a crispy fire. Then into thermodynamic properties, expansion scale. Increasing this value may actually cause high level of velocity. So I found out that any value above 1 gives me very unpredictable result, and it will extremely slow your scene down. So I'm actually going to disable it. And then we have radiative heating. By setting this to a high value, flame speed will increase. Again, we can increase the speed of our simulation differently, so I'm not going to use that. But radiative cooling is something that I tend to use a lot actually for fire simulation. If you add high value to this, flame speed will increase and fuel will ignite at the same time. If you randomize this radiative cooling, you will be getting some really cool and interesting looking results, because high values in this attribute is going to reduce the height of the flame, and low values increases the height of the flame. So this is one of those attributes that you definitely want to randomize to get a good result. Speaking of randomization, I can actually bring this guy, Control C, Control V. We call this randomize combustion. And you can actually go to thermodynamic properties and assign this value to radiative cooling, and then randomize your attribute. So I probably set a min of 0.5 and maximum of 1.5 maybe. I'm going to give this a rate of change 0.75, so that's 0.75 up and down of these values that we specified, to add a little bit of randomization. To see the effect better, I may actually go to my source air and really crank up this fog density just for us to see some results. Now after this, I'm going to play blast, and the next step would be to just put some colors in there, because we just don't want to see the puff of smoke. We want to look at some colors. We want to make the result look more interesting. So let's do a quick play blast and see what we're getting, and after that we're going to assign material. Look at that. So with only few changes we made, we managed to get some really interesting patterns and introduce them to our fuel. Believe it or not, we're almost there. Now, just do a quick recap on what we did to make that level of change in just a second. Well, thanks to our aero combustion settings, there's some really key attributes are in there. So let's review them one by one. Well, first things first, that expansion scale, we reduced it, and that reduces the explosive nature of our combustion. So if you want to get a really wild looking result, bring this down to something like 0 or very low value as much as you can. Another thing that always helps is to randomize your radiative cooling, because cooler gases don't rise as quickly. So we need to kind of get some help with this randomization. What we get in the pattern is going to be somewhat pleasing yet unpredictable. Now, another thing you can do to help the fire is actually on your aerosolver settings. So we've got aerosolver settings here. And if I go here, we've got the buoyancy, which acts as gravity. You can actually reduce the magnitude to help the hot gas rise less quickly if you feel like it. But we're not going to change it. I'm actually quite happy with the result. You don't want to smooth the velocity or anything, but I may in the future just a tad increase the simulation speed. I think the look of the fire looks pretty cool, but it's a tad slow for a realistic looking fire. But that's the attribute that you can change right after you assign material and have another look at it and see if you like it. Now to the material, obviously we need to press tab and then assign material. The good thing about this assign material is you can assign a volume or displacement or surface shader. It's quite diverse, but for this particular example, it's a no-brainer. A fire is a volumetric object. We need volume material. So aero volume goes to geometry, out geometry from assign material to sphere. Now for volume material, we do need a material. I'm just going to enable Hypershade. Now my volume shader is called AI standard volume. I should be able to find that under shader. You can always press tab here as well. I'm going to scroll down, AI standard volume. Obviously, if you have more than one pyro-dynamic, you name it. Otherwise, you just middle mouse straight in. Fantastic. I'm going to position it and link it to my material. So from material reference to material volume. Now here's the important part. I probably can minimize now. It's safe to say that I don't need my graph editor at the moment. I will bring my material here and let's tweak this a little bit. So first things first, starting with the volume itself. Density refers to the density attribute in AI standard volume, but we want to link that to the fog density that we have. So I'm going to change that from density to voxel fog density. Now what else we can do? I mean, I'm not going to use scatter as much. I won't be doing that. It's mainly for effects like clouds where the light scatters. Although you can play around with this attribute, slightly increase that to increase the not amount of scattering, but the way that the scatter shows in the render. The transparency, I tend to actually dial it down because, well, it needs to be transparent. Everything needs to be transparent. Now we are here in the black body and emission and temperature. Now these are some very, very important attributes. Channel this one set to heat and channel this one set to temperature. Again, these two refer back to AI standard volume that I have, but the way that Bifrost sees them is channel set to voxel temperature and temperature obviously set to voxel temperature, because you want to target voxel temperature in your Bifrost graph, not this node here. Now weight to 1, I honestly don't know if that's a good number, but we'll see. But what I know for sure is black body Kelvin to 5000 is massive. So I'm going to bring this down to probably 4, and maybe this black body intensity to something like 0.03. Now, if you would like to know more about these attributes, I highly suggest you to, I'm just going to bring this page here. I highly suggest you to see this page. So it's from Arnold. I put the link in the description below, but basically you can go through all of these attributes one by one and see what each attribute does. Make sure to check it out. Now back to Maya. So to make further changes, I'm going to go to my graph node and time to reduce this to something like 1. Obviously you can set it to 0 as well. That definitely works. Now that's going to get rid of that opaqueness of our fire. For the emission, I'm probably going to just reduce this just a tad, 0.8 for the weight, and a little bit lower the color. And for the temperature itself, 1 may be good. Let's start with 2 here and maybe 3.5. And yeah, definitely that has improved the look of the fire. Now from this point onward, it's going to be your choice. So you're gonna the look of this fire based on the reference you have, based on the brief that you have. There is really no right or wrong, but I highly suggest you to study your reference and try your best to match the coloration and pattern to your reference. But for now, I'm just going to probably pause the scene and then go into my Arnold render. Let's see what sort of a result we're getting now. Yes, definitely that looks interesting. So you can play around with the attributes. I would say these two rollouts would be the key ones. So you can increase, if you would like to have more brightness or more hot areas, you increase the black body Kelvin and you'll be getting the kind of oversaturated result. But I think for my purpose, something like 2 definitely works. If you would like to increase your temperature a little bit, you sure can. So you can increase that, and that introduces more yellowy temperature into your scene. As you can see, if you would like to get rid of the emission to get a kind of milder looking fire, you sure can. And again, there is really no right or wrong at this point, so I'll leave it to you to try it out. But for me, I'm just going to play blast this and see how this looks, because, well, I want to have a look at the shader, but also I would like to have a look at the flow and the speed of my fire and see how it's looking. So looking good. I'm going to save what I have right now and do a quick play blast, and then we'll be back and have a look at the result. Good. I love the flow. I may control the dissipation a little bit. Remember, we set it to 6. It was too high probably, and now 4 too low. Maybe 5 would be a good compromise. Also, the simulation speed is a little bit slow for my taste. So I'm going to go into my dissipation influence and set the dissipation to something like 4.25. So it's not exactly 4. And then if I go in here into Aero Solver settings, I may increase my simulation speed a little bit, and we are ready to go to cache our simulation. So if you want to cache, you can actually write it out just like this, but you can cache it if you want to. So for that, cache goes to object to objects, and that goes from first object to sphere mesh. You need to make sure that your file cache is set to write mode, and you need to make sure that this button here, that playback, is set to playback only once. So you need to have that little 1 in there. Now, hopefully you all have set projects before this session, because it actually writes these BOB files into the cache folder. So if I bring my folder structure, you can see everything is set inside cache. Now I created a Bifrost. So that's what you need, and inside that Bifrost is going to put the cache files. Now, just so you know, I'm going to bring back the Bifrost graph. This path needs to be accurate. So right now it's set to home, but just to be 100% sure, what I can do is just to click on this path, right click, copy, and then go in here just right before file. I can just Control V and paste my path. I can go one level forward and fix the /back/ situation. Properties set to all, Alembic interpolation to linear. Everything is ready to go. Obviously, last frame is 100 for our case. And we go active frame range. And then with that, all we need to do is just to play the time slider once and it's going to write all the cache files. I'm going to save, I need to rewind, and then press play, and it's going to write cache files. Now if I bring the file over, you can see it's writing cache files, and as we're going through the scene, those files get bigger and bigger. So make sure you have enough space, because they may get up to 1 gigabyte worth of file, and it will take a while. So I'm just going to wait for the cache to be written, and then we come back and render the scene, have one last look at the final result. So I went ahead and rendered 92 frames and exported my sequence renders into Nuke. And here I am inside Nuke. I added some glow nodes, a grade node, you can see after, before, after, to introduce a little bit of blue, and eventually wrote my sequence out. And that's the final result. Feel free to make adjustments, add dissipation, add resolution, introduce wind influence. So much you can do with the node graph and with the knowledge that you have. But it was just an introduction to the workflow, how you create fire. But of course, it will come down to what type of fire and your reference. But hopefully this video is going to help you to achieve the look that you want. I hope you enjoyed this tutorial, and see you in the next one.